All right, so this is a really nice breakout showing you how a simple problem, such as a percent yield, can be made more difficult by giving you information in a slightly different way than you're used to. So um, what we have here is that we have a balanced chemical equation. It's already balanced. And it's asking for how many grams of F2 are needed to produce. So this is actually a very realistic calculation that you would make in the lab, in that you need an X amount of product, in this case 140 grams, but the reaction doesn't have a 100% yield, it has something less than that. And so you basically have to account for loss. And so this problem is difficult in that way. And so what I would recommend in this particular problem, especially if you read the question, you're just like, huh, is to write out what you know. And so I like to start here, percent yield. I have a number here. So I'm just going to write out what the equation is for percent yield. So percent yield I know is equal to the actual yield. You could also put experimental yield there. Actual yield divided by the theoretical yield times 100%. So I then am going to put in the value. So I'm told that the reaction has a 65.6% yield. So I'm going to put it in 65.6% yield. Okay. Now, what I don't know is I'm also given a value here of 140 grams of the reaction. So you need to produce this amount. So need, meaning this is actually how much you want, so that the 140 grams is your actual yield. And so this is the key to the whole experiment, or the whole calculation, in that 100%. So now we have a simple algebraic problem where we would like to solve for x. And so I'm just going to, the simplest way to do this is to multiply by x and divide by the 65.6, or these are just going to swap places. It saves a couple steps. So we could have x is equal to 140 grams divided by, now this is a percent, so the other thing I'll do is I will divide by 100 for both of these. So if I divide this by 100, it goes away. Divide by 100 here, this becomes 0.656. So if we do that, again, a couple of math things there, then we know the theoretical value should be more than the actual yield. And so if we divide 140 by something less than 1, then we should get a larger number. And x turns out to be 213.4 grams of PF3. Now, conceptually, what is this value? This value is what we have to plan to make so that when we lose about 34.4% of our product, that we end up with the 140 grams that we need. Okay, so this would be the theoretical yield. Okay, and so the question, so now we have what the theoretical yield is, but the question is, how many grams of F2 is needed? So what we can do is we need to figure out, well, how many grams of F2 do we need to theoretically make PF3? So what we're going to do is we're going to start, so I now know I have 213.4 grams of PF3. So I need to go grams to moles of PF3 to moles of F2 using the mole ratio, and then to grams of F2, which is right here. So I'm going to go back using our grams of moles, moles of moles of grams, but now we're going to go backwards. The hardest part of this whole problem we already did, and that was calculating our theoretical yield and knowing that 140 grams was our actual yield. So we're going to go and do that. So I'm going to have 213.4 grams PF3. Now I should know how much PF3 weighs. Its mass is 87.94 grams of PF3 in 1 mole PF3 grams. PF3 cancel. So now you have moles PF3, and now we're going to look at the mole ratio. So I'm just going to write out the moles first. Mole PF3 and moles of F2 is what we want. And we look here, and we see that we have 4 PF3s for 6 F2. So 4 PF3 for 6 F2. And so that gets the moles PF3, and then we can multiply. We want to go from moles of F2 to grams of F2. So in 1 mole, it's 19 times 2. Each fluorine's 19.00. That's 38.00 grams. Moles of F2 go away, and I'm left with grams of F2, which is what I want. So I'm going to multiply this out, and I get 138.32 grams of F2. Now I go back to my original value. I only have percent yield. We have percent yield, it's 3 sig figs. And I have 140. Now 140 was only given to me as 2 sig figs because a 0 doesn't count. 2 sig figs. And so because of that, I'm going to have to make this, so I have 1, 2, so I have to stop it here, so I have to make this 140 grams of F2, or 1.4 times 10, because I had to go 1, 2, times 10 to the 2 grams of F2. Either one works, and in both cases is how much we need, so needed. So that's how you solve that breakout problem.